The world's biggest tunnel boring machine to an abrupt halt. It's jumped 1,000 feet into a tunnel that's planned to be almost 10,000 feet long. China has shocked the world with machines that seem to break the laws of physics.
China, you go there now, roads, bridges, schools, you never saw anything like it. They have bridges that make the George Washington Bridge look like small potatoes. And they're all over the place.
These mega machines get colossal jobs done faster, cheaper, and more efficiently than anyone imagined. Quietly, China has seized control of global mega construction. And today, an astonishing portion of the world's largest projects depends on its technology. What are these machines? How far can they push the limits of engineering? Join us as we reveal China's mega machines that have stunned experts and changed everything. Total world domination. At the turn of the millennium, China had no share of the global TBM market. The West had spent more than 150 years refining the technology, and the field was considered too specialized for latecomers. Yet by 2024, the picture looked like an alternate history. China dominated the market, supplying nearly every major project worldwide. While California spent 16 years and billions struggling to build a single high-speed rail line, China laid more than 40,000 kilometers of track in the same span, complete with tunnels, bridges, and viaducts. Linking megacities like pieces of an enormous Lego set, China transformed speed itself into strategy. What seemed impossible elsewhere became routine. So how do you condense a century and a half of progress into just 2 decades? Chinese engineers call it concentrating all national efforts on big issues. Instead of scattering research across firms and universities, China aligned its state, industries, and workforce toward a single mission. They imported machines, dissected them, rebuilt them, and scaled production with military precision. It was not evolution, but acceleration. This approach turned metaphor into reality. Where the West advanced slowly through competition and trial and error, China sliced away the delays and ran the process on fast forward. A century-long gap was erased in less than a quarter of the time. And it was no accident. By synchronizing industries, universities, and supply chains, China created a learning curve so steep that the West could not keep pace. Behind it stood an engineering army, 6.7 million students, trained with military discipline and funneled directly into national development. The machines may move mountains, but without people, they are powerless. And here lies China's greatest strength. While Western nations debate work-life balance, China has built the largest engineering education system on Earth. Millions of undergraduates are enrolled in more than 23,000 courses. This is not just a number. It is a workforce the size of a nation, disciplined, trained, and deployed into infrastructure and innovation. Each year, China produces 1.5 million engineers, 1/3 of the global supply. The United States graduates less than a quarter of that. So when critics ask how China can complete 10 high-speed rail lines while the West struggles with one, the answer is simple. The people exist to build them. In the West, construction stops for weekends, holidays, storms, or heat waves. In China, engineering is a campaign. Crews rotate in 3 shifts, working non-stop, 7 days a week through any weather. The machine never sleeps, and neither do its operators. A tunnel-boring leviathan can be seen grinding through rock at midnight, one crew finishing, another taking over, a third preparing behind them. It is not chaos, but choreography, drilled from classroom to worksite. Engineers are trained to treat impossibility as a challenge. not a barrier. The results speak for themselves. By the end of 2024, China held 3.5 million valid invention patents, more than half already in industrial use. In many Western nations, patents gather dust. In China, they are weapons of progress. This scale and discipline change everything. When a Western engineer says a bridge will take 5 years, a Chinese team can answer 1 year and deliver. In Chongqing, 6-lane highways rise in the time Los Angeles or London would still be debating permits. Now imagine 1.5 million fresh engineers entering the system every year. Imagine a country producing more engineers annually than the population of entire European cities. Multiply that by 2 decades, and what you see is not a workforce but a force of nature. And it is not just about numbers. It is about direction. Millions of minds are steered toward mega projects, artificial intelligence, energy, and the machines that turn the impossible into routine. Where the U.S. might take a decade to design and approve a new TBM, China produced multiple models in the same span, refining each version and cutting costs through scale. Consider the timeline. In 2008, as Beijing prepared for the Olympics, China still relied on foreign tunnel boring machines. By 2011, just 3 years later, the first domestically produced model rolled out. By 2017, exports were reaching more than 30 countries. Today, 7 out of 10 tunnel boring machines carving through the earth bear the mark made in China. And as if dominating the world's tunnels wasn't enough, China has now built a one-of-a-kind machine unlike anything the world has ever seen. China's TBMS that break physics. Designed and built by Chinese engineers, China's tunnel boring machines excel in the most demanding conditions. From soft soil in megacities to earthquake-prone zones, carving tunnels faster, safer, and with unmatched precision. Some of these machines can excavate up to 10 kilometers of tunnel in a single day at a cost of just $10 million, a fraction of the $50 million per kilometer typically spent in the United States. A standout example is the CRCHI TBM, domestically constructive, which completed the excavation of one of the twin tubes of the Jensen East Road Highway beneath the Qiantang River in Heo, China. Measuring 15 meters in diameter, it is one of the widest tunneling machines in the world. With a power output of nearly 10,000 kilowatts, torque exceeding 42,000 Newton meters, and a top excavation speed of 50 millimeters per minute, the CRCHI demonstrates the scale and efficiency of Chinese engineering. The Caucasian TBM further exemplifies China's ambition. With an excavation diameter of 15.08 meters, a total length of 182 meters, and a weight of 3,900 tons, it ranks among the largest single-shield hard rock TBMS globally. Its massive size allows it to move enormous volumes of earth efficiently, completing work that would take months in just weeks, all while maintaining perfect stability and safety. China's TBMs rely on an advanced slurry shield system that enables them to thrive in soft ground and seismic regions. This system balances pressure between the excavation chamber and surrounding soil, preventing surface settlement and protecting densely populated areas. Hydraulic jacks and articulated joints allow the machines to adapt to shifting ground, while the slurry cushions tunnels from vibrations, ensuring safety even in quake-prone zones. These machines power China's most ambitious infrastructure projects. On the Ningbo-Zhoushan high-speed rail line, the Jintang Subsea Tunnel is being excavated using a 14.6-meter diameter, 4,350-ton TBM, the world's largest for subsea high-speed rail. In Guangzhou, a 15.07-meter TBM carved the Haizhu Bay Tunnel with minimal disruption to the bustling city above, demonstrating China's ability to combine immense power with precise control. Every Chinese TBM is equipped with intelligent control systems that monitor cutter head torque, thrust, and ground pressure, adjusting in real time to optimize efficiency and reduce errors. Integrated geological mapping and sensor data allow these machines to anticipate changes in soil, maintaining speed, safety, and structural integrity. Advanced TBMs like the independently developed Linghang also support intelligent excavation, remote operation, tail-end safety monitoring, and automated adjustments for complex geological conditions. China's TBM revolution began in the early 2000s. When China Railway Group Limited decided to develop its own machines, many considered it impossible. Wang Dujuan, chief engineer at China Railway High-Tech Industry Corporation, recalled that early engineers had never even seen a TBM in operation. With over 20,000 components per machine and more than 2,000 control points in the system, the challenge was enormous. In 2008, China unveiled its first domestically developed Earth Pressure Balance TBM China Railway No. 1, marking a milestone in independent engineering. By February 2009, it began work on a Tianjin metro project, completing the tunnel in just 4 months while controlling ground settlement within 3 millimeters. The domestic TBM industry rapidly grew, led by innovators such as China Railway Engineering Equipment Group, China Railway Construction Heavy Industry, and CC Tianhe Mechanical Equipment Manufacturing. A breakthrough was mastering ultra-large main bearings, the heart of these machines. Bearings must withstand extreme loads continuously while ensuring reliability and long service life. Chinese engineers conducted thousands of tests, experimented with hundreds of materials, and collaborated with specialty steel companies to produce bearings capable of supporting the world's largest TBMS. On October 12, 2023, ZRCHI produced a main bearing measuring 8.61 meters in diameter, the largest, heaviest, and highest capacity ever made. Chinese TBMS are increasingly intelligent. Systems monitor wear and temperature on cutting tools and slurry pipes, or predict potential damage and provide real-time feedback to operators. This integration of automation and data enables faster, safer, and more precise tunneling than ever before. China hasn't just accomplished construction feats once deemed impossible. It has completed them in record-breaking time, as shown in 2015 and 2020. The 19 Days Wonder. The Mini Sky City project in Changsha, Hunan Province, China, stands as one of the most remarkable feats of rapid construction in modern history. Completed by Broad Sustainable Building, or BSB, in 2015, the 50-story skyscraper was assembled in just 19 days, an average of 3 floors per day. This extraordinary case highlights both the innovation and efficiency of the construction techniques and equipment employed. BSB used a prefabricated modular construction method, manufacturing sections of the building off-site before transporting them to the site. These modules were engineered for quick assembly, dramatically reducing the time required for on-site construction. Each of the 2,736 modules was crafted with precision, allowing them to fit together seamlessly. This method not only accelerated construction, but also ensured high quality, minimized weight, and reduced environmental impact compared to conventional building methods. The project was carefully planned and executed, with every step synchronized for speed and accuracy. By completing a high-rise in under 3 weeks, BSB set a new global benchmark for rapid construction, drawing attention across the industry where efficiency is critical. China's record-breaking construction didn't stop at skyscrapers. In response to the COVID-19 crisis, the Huoshan Shan Hospital in Wuhan was built in 10 days, a staggering achievement in large-scale infrastructure. Initiated on January 23, 2020, this 1,000-bed hospital was fully operational by February 2, 2020, providing crucial medical capacity during an unprecedented health emergency. Like Mini Sky City, the hospital relied on prefabricated modular units, allowing site preparation and module construction to occur simultaneously. This parallel workflow saved enormous time while maintaining consistent quality. Each unit was produced under controlled conditions, reducing on-site errors and delays. The speed of construction was powered by a massive workforce and continuous operations. Over 7,000 workers, including engineers, electricians, and volunteers, labored in rotating shifts to maintain progress around the clock. Cranes, trucks, and machinery moved ceaselessly, while precise coordination between government agencies, construction firms, and suppliers ensured seamless logistics. China's robust supply chains and industrial capacity were essential, delivering materials, labor, and equipment without interruption. These extraordinary projects were made possible not just by manpower and meticulous planning, but by China's fleet of state-of-the-art construction machines, engineering marvels that redefine what's possible. But what other advanced Chinese machines are shaping the world's skyline today? The Iron Monster. The SLJ 932, known in China as the Iron Monster, is one of the largest bridge-building machines on Earth. Built by the Beijing Wao Joint Machinery Company and designed by the Shijiazhuang Railway Design Institute, it measures 91 meters long, 7 meters wide, and 100 meters high meters wide, and 9 meters tall. At 580 tons, it is heavier than some warships and among the longest land vehicles ever created. Unlike ordinary cranes, which can only lift small sections and need space to operate, the Iron Monster handles entire bridge spans weighing up to 950 tons. It lifts a massive concrete beam under its frame, drives it to the edge, locks itself onto a pillar, extends forward, and lowers the section into place. Then it rolls ahead and repeats the process, span by span, until a bridge stretches across the gap. Its mobility is just as remarkable. The machine runs on 60 core wheels, grouped into fours, and each group can pivot 90 degrees. This allows the giant to move sideways with precision, sliding beams into place as smoothly as a hand pushing a plate across a table. Despite its size, the Iron Monster moves steadily, 8 kilometers per hour when empty and 5 when loaded. Over its lifetime, one machine can set between 700 and 1,000 spans before retiring. From the outside, it might look like a giant transporter, but it was built for a single purpose: constructing high-speed rail bridges in places where tracks must cross deep valleys and wide canyons. By combining lifting, carrying, and placing into one vehicle, it removes the need for scaffolding or towering cranes. The method is simple but revolutionary. The machine drives to the edge, raises a prefabricated beam, stretches across to the next pillar, blocks in, and sets the span. Then, it advances over the section it just placed and does it again. Each beam connects with expansion joints, forming a continuous, durable bridge far faster than traditional methods allow. The advantages are enormous. Conventional building demands more labor, smaller pieces, and far more time. The Iron Monster cuts all of that down: fewer workers, fewer parts, and unmatched speed. It is also built with safety in mind. Each unit is designed to carry loads heavier than any train that will ever pass over its bridges. Its skilled crews, trained to work at great heights and in extreme conditions, operate the machine with military precision, ensuring flawless performance. What once took decades can now be done in just a few years. Already, iron monsters have helped China expand its high-speed rail network beyond 30,000 kilometers, building bridges at a pace no other nation has matched. Western engineers once doubted it, saying, "It shouldn't even work." But it does, relentlessly, efficiently, and on a scale that makes traditional cranes look like relics of the past. If the iron monster impresses, the next machine, a colossal transport erect machine that will leave you speechless. Kunlun. Named after one of Asia's longest mountain ranges, Kunlun was developed by China Railway Construction Corporation Limited to lift and position massive box girders over challenging terrain, from mountains to rivers, with unmatched precision and efficiency. Kunlun is the world's first transport erect machine capable of handling a 1,000-ton box girder, performing the work of 3 traditional girder erection machines, while operating on ramps with slopes up to 30 degrees and curved tracks with tight radii. It can erect girders of 24, 32, and 40 meters, allowing China to build bridges for its high-speed railways at an unprecedented scale and speed. The machine is lighter than traditional alternatives, yet stronger, constructed with high-strength steel plates used in aviation and submarines, ensuring both durability and agility. In June 2020, Kunlun completed its final heavy-duty test, and soon afterward erected the first 1,000-ton box girder for the Fuji and Xiamen high-speed railway bridge. This nearly 15-kilometer cross-sea bridge was completed in September 2023, astonishingly faster than the 4 years it took to construct the 3-kilometer Golden Gate Bridge. Kunlun's ability to handle such massive girders reduces train resonance, ensuring stable operation of high speeds and supporting China's entry into the 400-kilometer-per-hour era. Kunlun features advanced intelligent technologies, including laser matrix systems or autonomous navigation through tunnels, real-time monitoring of girder positions, automated transport and placement, and precise integration with the Railway Engineering Management Center's information and maintenance platforms. Operators can track girder conditions in real time, enhancing both safety and efficiency. These innovations reduce construction costs by about 20% and accelerate erection speed by 25%, all while requiring less space than conventional machinings. The machine has proven its versatility in multiple projects. On the Zhengzhou-Chongqing high-speed railway, where more than 90% of the Chongqing section consists of bridges and tunnels, Kunlun has operated on steep ramps and tight curves, demonstrating flexibility far beyond traditional equipment. Over the past year, it has placed beams at tunnel entrances and exits across western China's rugged terrain, proving its ability to tackle some of the nation's most challenging landscapes. On the Fuzhou-Xiamen Railway, China's first cross-sea high-speed line, Kunlun's erection of 1,000-ton, 40-meter girders has improved navigation capacity, reduced tidal impact, and enhanced bridge safety. This machine doesn't just shatter records, it makes the impossible look routine. And if that sounds unbelievable, wait until you see the world's most powerful crawler crane, the XCMG XGC 88,000. On paper, it sounds impossible. A crane that can lift 4,000 tons with a boom stretching 144 meters into the sky and a total weight exceeding 5,300 tons. To put that in perspective, it could hoist a fully loaded Airbus A380 with ease. This is the XGC 88,000, an ultra-heavy crawler crane built by XCMG. Entering production in 2013, it became the largest tracked mobile crane in the world, surpassing the Liebherr LR 13000. It also ranks among the largest self-propelled ground vehicles ever built, even outsizing NASA's famous crawler transporter. While the Honghai crane still holds records for sheer size, the XGC 88000 is unmatched for mobility and versatility. The crane consists of two main sections. The first is the machine itself, with a maximum boom length of 144 meters, an overall length of 173 meters, including the counterweight radius, a height of 108 meters, and a lifting capacity of 30,600 to 4,000 tons. In practice, it has handled overloads up to 4,500 tons and achieves a lifting moment of 88,000 ton-meters. Three Cummins engines, each producing 641 kilowatts, combine for nearly 2,579 horsepower, powering the machine and supporting assembly, disassembly, or backup functions. The operator sits in a spacious cabin the size of a small office, complete with air conditioning, a comfortable seat, and even a sofa for 3 passengers. The second section is the tracked counterweight compartment, standing 9.7 meters tall, 29 meters long, and weighing 2,900 ton. It has its own driver's cockpit and requires a working radius of 29 meters. Together, the entire crane tips the scales at nearly 5,400 tons. Designed for petrochemical, nuclear, and chemical industries, the XGC 88000 handles massive components with remarkable precision. Its boom can be configured in multiple ways: a 120-meter heavy boom, a 140-meter light boom, and an optional 33-meter jib. This flexibility allows it to adapt to nearly any construction condition while maintaining full load shift for maximum mobility and efficiency. Since entering service, the crane has lifted modules larger than small buildings, executing moves that would leave conventional cranes struggling. Watching it in action is like watching gravity itself bend, a performance decades ahead of what Western engineers achieved with smaller machines. And while this crane dominates the skies, China's engineering ambitions do not stop there. The next spectacle comes in a task most would consider mundane: concrete pumping transformed into a feat of scale that is nothing short of national ambition. The Pump King. When workers built the Shanghai Tower, they faced a daunting challenge: pumping concrete nearly 2/3 of a kilometer into the sky. Most pumps in the West would falter after a few hundred feet. China's Sany 86-meter pump shattered the world record, sending wet cement 621 meters high, higher than the Eiffel Tower. It performed so flawlessly that it earned the nickname Hump King. As of 2024, it holds the Guinness World Record for the longest truck-mounted concrete boom, thanks to its meticulous design, advanced materials, and precise engineering. It has redefined what is possible in high-rise and large-scale construction. The pump's boom has 7 sections, longer and more flexible than conventional 5- or 6-section designs. This allows operators to reach confined urban sites and complex terrains with ease. Constructed from high-strength 1,800 megapascal steel, the boom maintains stability under immense pressure during extreme high-rise pumping. Mounted on a 9-axle all-terrain chassis, it offers superior mobility and stability, featuring advanced suspension and multiple steering modes, including crab and diagonal steering or tight maneuvering. Operating the Pump King is equally impressive. Its automatic boom system enables one-touch deployment, vertical and horizontal pumping, boom locking, and area limiting. Advanced stabilization reduces boom shaking by 50% and cuts the swinging range of the revolving tower by 60%, ensuring precision and safety. Energy-saving technology boosts operational efficiency by 25%, while cutting fuel consumption by 10%. Its self-diagnosis system can detect over 150 types of malfunctions, helping operators troubleshoot quickly and minimize downtime. The Pumpkin has made a global mark on high-rise construction. On projects like the Shanghai Tower, it pumped ultra-high-strength concrete to 620 meters, a world record at the time. Its precision and reach allow China to construct skyscrapers faster, safer, and more efficiently than ever before. Durability and low maintenance are central to its design. The pump's piston can handle 25,000 to 30,000 cubic meters of concrete before needing replacement. Components are crafted from advanced Sino-German materials resistant to wear and tear. Returning to railway construction, China pushed the limits of engineering with a machine that seems to defy the laws of physics. CYP 500. China's CYP 500 track-laying machine is capable of laying 2 kilometers of track in a single day. It operates 24 hours straight, transforming railway construction into a continuous, high-efficiency process. In March 2020, the CYP 500 made its Southeast Asia debut on the China-Laos Railway. There, it installed a 500-meter steel track in Vientiane, marking the first section of the railway and the longest steel track outside China in Asia. The machine performed flawlessly, surpassing its daily construction goal of 1.5 kilometers with ease. Designed for high-capacity, large-scale projects, the CYP 500 integrates track laying, alignment, and precise placement into a single automated workflow. Its continuous operation minimizes downtime, while its advanced control systems ensure rails are positioned with millimeter-level accuracy. The machine's capabilities allow it to tackle challenging terrain, complex curves, and long bridges or tunnels, keeping pace with even the most demanding construction schedules. In just 4 years, CYP 500 technology has increased China's track-laying capacity from 500 meters to 2 kilometers per day, setting new standards in efficiency. The secret behind China's ability to construct towering skyscrapers in record time lies in the next machines. Bow knot. This wall-climbing construction giant, engineered to transform high-rise buildings, standing over 40 meters tall and weighing nearly 2,000 tons, it dramatically accelerates construction speed, completing a floor in just 4 days, over 20% faster than conventional methods. Unlike traditional cranes, the boat knot does not rely on external scaffolding. Its reinforced steel frame, combined with integrated hydraulic and automated systems, allows it to lift and assemble prefabricated panels, girders, and beams while maintaining absolute stability. Advanced sensors continuously monitor stress, tilt, and load distribution, preventing structural errors even at extreme heights. One of the machine's most remarkable features is its vertical climbing system. After completing a floor, it elevates itself to the next level without disassembly or repositioning. Hydraulically controlled jacks and counterweights maintain equilibrium during ascent, while automated controls adjust for wind forces, structural shifts, and weight distribution. This continuous vertical mobility enables the bow knot to operate without interruption, maintaining precision placement of every component. The bow knot is equipped with sophisticated automation and precision control systems. Sensors and software measure, align, and adjust structural elements in real time, allowing the machine to perform heavy lifting, precise alignment, and assembly with minimal human input. Operators control the entire process from a protected cabin, monitoring load distribution, material placement, and structural alignment. Its intelligent algorithms can make minor corrections automatically, ensuring smooth operation under variable conditions. Constructed with high-strength, lightweight materials comparable to aviation and submarine engineering, the Baorat's frame features redundancy systems, stabilizers, and counterweights to prevent tipping. Even in hurricane-level winds, the machine maintains stability, performing multiple tasks simultaneously, lifting, aligning, and assembling structural components. By reducing labor requirements at hazardous heights, it ensures safety while maintaining unprecedented construction speed. The most surprising thing about these mega machines is that they aren't confined to China. They can be deployed anywhere in the world, thanks to a purpose-built mega vessel designed to transport them safely and efficiently. Yiheng Jinyun 2. This is a semi-submersible heavy-lift vessel purpose-built to transport oversized and project cargo, including 10-megawatt offshore wind turbines and their components. Built for versatility, it handles a broad range of shipping and civil engineering tasks, from transporting raw materials like sand and gravel to carrying ro-ro freight and irregular loads. Its open deck is optimized for heavy, oversized, or uniquely shaped cargo, allowing the vessel to operate efficiently in both coastal and offshore environments. Measuring 115.2 meters in length with a 26-meter beam and a 6.6-meter depth, Yiheng Jinyun 2 provides a stable platform for heavy cargo operations. Its 2,000 square meter depth can accommodate up to 6,000 tons of material, while reinforced structures allow it to carry vehicles, including 60-ton trucks, safely. The superstructure is positioned near the bow to maximize the stern deck, facilitating efficient loading and unloading. Adjustable pillars, modular deck fittings, and a reinforced springboard system make it capable of handling irregular cargo, including disabled ships, while distributing weight evenly to reduce deck stress. The vessel's propulsion and positioning systems combine power and precision. Twin main engines drive fixed-hitch propellers, supported by a Vaux tunnel thruster and a 4-point mooring system, allowing accurate placement even under Beaufort Force 6 winds. This setup lets the ship operate independently in most offshore scenarios, reducing the need for tugboats and improving operational efficiency. Advanced automation enhances both performance and sustainability. An intelligent energy management system monitors propulsion, onboard machinery, and navigation in real time, optimizing power distribution and fuel consumption. Predictive maintenance technology provides early warnings of potential mechanical issues, allowing scheduled servicing before failures occur. Combined with its modular deck and load optimization features, these systems enable safe, efficient, and environmentally responsible heavy lift operations. Yiheng Jinyun 2's deck is designed for maximum flexibility. With the superstructure at the bow, the expansive stern remains clear for handling heavy or irregular cargo. Engine ducts and exhaust funnels are positioned along the sides to keep the central deck unobstructed, while removable pillars allow the layout to adapt to varying loads. These features, along with the reinforced springboard system, make it a highly versatile platform for complex offshore construction and cargo transport. Purpose-built for civil engineering, offshore construction, and heavy cargo transport, the Yiheng Jinyun 2 excels at carrying wind turbine components, prefabricated structural sections, and other large-scale project cargo over long distances. Its robust depth, precise positioning systems, and load handling capacity ensure that it can safely transport up to 6,000 tons per voyage, supporting high-value and oversized cargo, where stability, efficiency, and careful handling are essential. The vessel is particularly suited for renewable energy projects, coastal construction, and infrastructure initiatives requiring reliable, heavy-lift maritime solutions. Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.